On November 7, 1943, under a gray autumn sky above France, Lieutenant William E. Roach of the 358th Fighter Group found himself hopelessly disoriented after escorting bombers deep into German territory. Low on fuel and with his P-47D Thunderbolt's navigation system malfunctioning, he descended through heavy cloud cover, mistaking a German airstrip near Caen for an Allied base. Moments later, as his wheels touched the tarmac, armed Luftwaffe soldiers surrounded his aircraft, realizing with stunned disbelief that one of America's most formidable fighters had just landed intact in their possession. Within hours, the Thunderbolt, codenamed Beetle, was disassembled, loaded onto transport trucks, and sent under heavy guard to Germany's top-secret Rechlin test facility for immediate technical examination. Inside Rechlin's sprawling hangars, engineers and officers gathered around the captured machine with an intensity reserved for sacred relics. The P-47 represented the newest generation of Allied engineering, a 10-ton behemoth driven by the Pratt & Whitney R-2800 double Wasp engine, capable of withstanding damage that would destroy any German fighter. Its massive frame, rugged air-cooled radial engine, and sophisticated turbosupercharger system defied everything the Luftwaffe believed about high-altitude combat performance. When Chief Test Pilot Hans Werner Lerche first approached the aircraft, he noted its extraordinary construction, riveted panels that showed uniformity impossible under German wartime conditions. Every bolt, every joint, every hydraulic line seemed designed for efficiency, endurance, and speed of mass production. Even before flight testing, Lerche understood that the P-47 was not merely a fighter. It was an industrial statement, forged by a nation whose factories ran uninterrupted day and night. Midway through this historic examination, German officers invited Luftwaffe engineers from Junkers and Messerschmitt to inspect the captured Thunderbolt. Their reactions bordered on disbelief. Some dismissed the aircraft's heavy frame as wasteful until they saw its combat records. Altitude ceilings beyond 40,000 feet, dive speeds exceeding 700 kilometers per hour, and firepower unmatched by any German design. The realization struck with brutal clarity. The Thunderbolt's strength came not from exotic design secrets, but from the scale and precision of American manufacturing. This revelation sent shockwaves through technical divisions of the Luftwaffe, compelling senior analysts to reassess every assumption about Allied fighter development. For more gripping stories of forgotten wartime breakthroughs, like, share, and subscribe to uncover the technology that decided victory. When the captured Thunderbolt arrived at the Rechlin Luftwaffe Test Center, engineers treated it like a metallic puzzle from another world, each bolt and cable holding secrets to America's aerial dominance. Under the glare of floodlights, German technicians dismantled the aircraft methodically, layer by layer, like archaeologists unearthing the remains of a lost civilization whose tools were far beyond their own. The massive Pratt & Whitney R-2800 double Wasp engine, 2 rows of 9 cylinders, sat like a mechanical heart pulsing with the promise of unstoppable energy, its reliability shocking those accustomed to the temperamental nature of Daimler-Benz power plants. Every inspection revealed marvels of precision machining that felt impossible under Germany's strained industrial conditions. Metallurgical analysis of the Thunderbolt's engine alloys showed heat resistance unmatched by domestic German metals, its turbines polished to mirror-like perfection that reduced friction and preserved efficiency even under punishing strain. The German scientists, accustomed to intricate liquid-cooled systems, stared in disbelief at the air-cooled radial engine, which seemed almost primitive yet endured punishment that would cripple a Bf-109 or FW-190. Most astonishing of all was the turbosupercharger system, an intricate labyrinth of ducting and turbines located in the rear fuselage, driven by exhaust gases and capable of maintaining horsepower even above 30,000 feet. To German engineers, it was as if the Thunderbolt carried a miniature factory inside its fuselage, refining raw power out of thin air. Unlike their own superchargers, which demanded complex mechanical linkages, the American design used thermodynamics and precision metallurgy to create a seamless cycle of thrust and cooling. Test pilot Hans Werner Lerche described his first flight as a revelation in brute stability, noting that the P-47 accelerated like a descending hammer and maintained structural coherence even under crushing aerodynamic forces. In dives that would tear apart German fighters, the Thunderbolt held together as though carved from solid steel. Its 850 caliber Browning machine guns, harmonized with surgical precision, produced recoil so balanced it felt more like an industrial cutting torch than a weapon. The Luftwaffe engineers, after weeks of dissection and flight analysis, reached a chilling conclusion. This machine was not designed for elegance or artistry. It was built for endurance, for mass replication, and for war on an industrial scale. Inside the Rechlin laboratories, the deeper the German engineers delved into the Thunderbolt's construction, the more unsettling the discoveries became, revealing not just superior craftsmanship, but an entire industrial philosophy hidden within its rivets and steel. Each component carried the signature of a nation whose factories ran with mathematical precision, where every worker, machine, and process followed an orchestration that even the Reich's most efficient plants could not rival. The Thunderbolt's immense airframe, though seemingly bulky, reflected a design principle born of abundance, where weight could be tolerated because power was limitless and reliability mattered more than perfection. While German aircraft like the Bf-109 relied on delicate tolerances and hand-fitted parts, the P-47's modular construction was a testament to mass production mastery. The Americans had built a fighter that could be repaired in hours, assembled in factories by unskilled hands, and shipped across oceans ready for combat without intricate tuning. At Rechlin, this realization struck the German engineers harder than the aircraft's armor plating. It meant the Allies were waging a form of warfare that transcended battlefields entirely, rooted instead in logistics, labor organization, and sheer manufacturing muscle. Hans-Werner Lerche and his team documented every system with meticulous precision, but even their detailed notes betrayed quiet despair. They understood that no amount of tactical brilliance or mechanical ingenuity could compensate for such industrial disparity. The Thunderbolt's turbosupercharger alone required advanced heat-resistant alloys that Germany could no longer produce in quantity due to shortages of nickel and chromium. Every turbine blade, every compression housing, represented a triumph of materials science fueled by a limitless resource pool that Nazi Germany simply did not possess. For the Luftwaffe, the P-47's analysis was more than technical. It was prophetic. It demonstrated that the Americans had transformed their civilian industrial base into a machine of war that produced excellence through repetition rather than craftsmanship. Where German design sought aesthetic precision, American engineering sought endurance, ease of maintenance, and standardized perfection under stress. As Rechlin's final report circulated among Luftwaffe command, a silent acknowledgement spread through its recipients. The war in the air was no longer a contest of pilots and machines. It was a contest of economies. In the cold November air of Rechlin, silence filled the test hangar as German engineers gathered around the stripped fuselage of the Thunderbolt, each man wrestling with an unspoken truth that was heavier than any armor plate they had examined. The Luftwaffe's finest technicians, men who had prided themselves on precision, innovation, and mechanical artistry, now found themselves face to face with a machine that embodied everything Germany could not replicate. The P-47 was not just an aircraft. It was an industrial philosophy forged in steel and powered by a system of limitless capacity. For years, German propaganda had mocked American manufacturing, portraying Allied machines as crude and inferior, yet here lay undeniable proof of the opposite. Every bolt, every wire harness, every hydraulic fitting was standardized to perfection, designed for replacement rather than repair, and built by an economy that could produce thousands without hesitation. When engineer Otto Behrens measured the tolerances within the turbo-supercharger assembly, he reportedly murmured that Germany would need an entire factory devoted solely to match that single component's precision. The words hung in the air like a funeral bell for an empire of craftsmanship overtaken by the age of production. In internal memos later declassified, Luftwaffe scientists admitted that their designs had reached their limits. They could create extraordinary prototypes, but they could never match America's ability to turn one idea into 10,000 functioning machines within months. For the first time, the myth of German technical invincibility fractured beneath the weight of numbers. The engineers realized that American factories were not building weapons. They were building systems that could outlast every loss, every failure, every battlefield setback. Some accounts describe that as Hans Werner Lerche completed his flight evaluations of the Thunderbolt, his post-flight report included a line that subtly acknowledged this industrial imbalance. We can copy its design, but not the means of its creation. It was a statement of profound resignation, for the engineers knew that behind every American pilot stood the power of Detroit, Buffalo, and Seattle, cities transformed into arsenals of democracy. In that hangar, surrounded by blueprints, oil stains, and silence, the German engineers finally understood that they were no longer losing battles in the sky. They were losing to an entire civilization's ability to build faster than destruction itself. By early December 1943, the disassembled Thunderbolt lay meticulously documented, every component catalogued by the engineers of the Luftwaffe's Erprobungsstelle Rechlin. The technical division prepared its official report, bound in thick folders marked Geheime Kommandosache, a designation reserved for the most confidential materials in the Third Reich. Within those pages, written in precise technical language, lay conclusions far more alarming than any field intelligence from the front. When the report arrived in Berlin, addressed to the Luftwaffe High Command's Development Office, its message would strike deeper than any Allied bombing raid. The document opened with an exhaustive mechanical summary, engine compression ratios, supercharger pressures, and airframe stress tolerances, but its tone shifted quickly from analytical to sobering. The P-47 Thunderbolt demonstrates performance and resilience beyond current German production capabilities, the report stated, acknowledging the near-impossible challenge of replicating its power plant technology under wartime conditions. The engineers highlighted the turbosupercharger's altitude efficiency curve, noting that the system maintained full power beyond 30,000 feet, a height where most German piston engines began gasping for air. This revelation alone meant that American fighters could engage Luftwaffe bomb interceptors at ranges previously thought unreachable. General Ernst Udet's successor within the technical office, Major General Ulrich Diesing, reportedly read the findings twice before setting the folder aside in silence. He understood the strategic implications immediately. No matter how skilled Germany's pilots remained, industrial and technical disparities would only widen with each passing month. When briefed before senior command staff, Diesing remarked that while Germany could improve its designs, it could never equal the scale of American output. The Rechlin report also included a section labeled Material-wissenschaftliche Bewertung, Material Science Evaluation. Here, metallurgical specialists compared the alloys used in the Thunderbolt's engine cylinders and control surfaces to those of the Focke-Wulf 190. The conclusion was humiliating. America's metallurgical precision yielded stronger components with fewer production flaws, the result of industrial chemistry far beyond Germany's strained wartime capacity. In subsequent intelligence meetings, Luftwaffe staff began to realize that the Thunderbolt symbolized something far larger than a single aircraft. It represented a civilization organized entirely for war production. The Rechlin findings circulated discreetly among senior officers, sparking quiet conversations that questioned whether technical mastery without industrial abundance could ever sustain victory. By January 1944, while engineers in Berlin debated the implications of the Rechlin findings, the Western Front had already begun proving them true. In the skies above France and the Netherlands, Luftwaffe interceptor groups faced growing numbers of P-47 Thunderbolts escorting massive formations of B-17s and B-24s. What had once been seen as cumbersome American machines now appeared as invincible guardians, their rugged design absorbing punishment that would have torn German fighters apart. Pilots who had once mocked the Thunderbolt's bulk now whispered with disbelief about its ability to dive faster, climb higher, and keep flying after absorbing hits from 20mm cannon shells. Major Gunther Rahl later recalled his first encounter, describing how his Focke-Wulf 190 struggled to pursue a diving Thunderbolt whose speed exceeded structural safety limits for any German aircraft. The Thunderbolt's turbo-supercharged engine delivered relentless power at altitudes where Luftwaffe planes suffocated. Even the P-47's sheer mass became a weapon. Its dives reached nearly 500 miles per hour, allowing pilots to disengage at will and re-enter combat on their own terms. By February 1944, Luftwaffe Command noted with alarm that Thunderbolts were increasingly dictating the terms of every engagement. In the ready rooms of Jagdgeschwader 26, conversations shifted from bravado to quiet recognition. Pilots studied captured performance charts and realized their enemy had mastered not just aerodynamics, but industrial mathematics. Each replacement Thunderbolt represented an assembly line that never slept, while each lost Focke-Wulf represented a craftsman's work that Germany could scarcely afford to repeat. Every dogfight became not merely an exchange of gunfire, but a collision between two economies, one built on quantity and standardization, the other on scarcity and precision. When American fuel convoys and logistics trains moved effortlessly from factory to front line, Luftwaffe officers began understanding what the engineers at Rechlin had already confessed. They were confronting a machine designed by a nation that had mastered production warfare. A single P-47 was not just a fighter. It was the culmination of thousands of engineers, machinists, and assembly workers functioning with seamless coordination. As the first reports of entire bomber formations returning untouched from deep raids reached Berlin, the Luftwaffe's pilots finally accepted a grim truth. The enemy's strength no longer lay only in men or tactics. It lay in the unbreakable rhythm of machines feeding machines across an ocean. By spring 1944, the Luftwaffe's technical department scrambled to answer the questions raised by the Thunderbolt's superiority, initiating emergency programs that sought to replicate its performance without the industrial foundation that made it possible. The Reich's Ministry of Aviation, under Erhard Milch's exhausted direction, ordered intensified research into turbocharging systems, but Germany lacked the critical alloys necessary to withstand the heat and pressure of high-altitude compression. Engineers at Junkers and Daimler-Benz experimented with mechanical superchargers, yet every prototype proved fragile and inefficient compared to the robust turbosupercharger integrated within the P-47's Pratt and Whitney R2800 engine. Each test bench failure became another symbol of an empire straining against its own industrial limits. Desperation grew in the conference rooms of the Air Ministry as reports from Rechlin and frontline units painted the same picture. The Allies had achieved technological balance through mass production, while Germany pursued perfection at unsustainable cost. Field Marshal Milch himself lamented that German factories required weeks to produce components the Americans delivered in hours. When technical officers presented proposals for a domestic turbo-supercharger, production specialists responded that raw materials like nickel and tungsten had already been diverted to panzer armor. Even if the designs succeeded, they would never reach operational scale. Meanwhile, Allied bombing raids further crippled what remained of Germany's research infrastructure. The destruction of the Magdeburg and Dessau facilities erased months of testing data overnight, leaving engineers to rebuild experiments from memory. American bombers flying above 25,000 feet operated with near impunity, their P-47 escorts untouchable in the thin stratospheric air. For every Thunderbolt downed, 10 more replaced it before German intelligence could even process the loss report. In the corridors of the Luftwaffe Technical Office, frustration turned to resignation. Reports circulated describing American aircraft factories operating 24 hours a day, their automated tooling lines producing airframes faster than German assembly crews could rivet one. The Thunderbolt became a physical manifestation of industrial totality, proving that innovation alone could not defeat mechanized abundance. By the summer of 1944, even test pilot Hans-Werner Lerche privately admitted that the future belonged to nations capable of fusing science with mass production. Germany, once the workshop of Europe, had become a craftsman's nation in a world ruled by factories. By late summer 1944, as Allied forces advanced through France and American bombers ranged freely over German territory, the psychological erosion within the Luftwaffe's technical hierarchy became unmistakable. The once celebrated belief that superior engineering could offset numerical inferiority crumbled under relentless empirical evidence. Rechlin's test pilots had flown the captured Thunderbolt hundreds of times, recording its characteristics with clinical precision. Yet every chart, every graph, and every data point told the same unforgiving truth. The United States had achieved a synthesis of durability, power, and production that no German design philosophy could challenge. Officers who once lectured about aerodynamic purity now spoke in hushed tones about resource exhaustion, factory losses, and the futility of pursuing perfect machines amid material collapse. The Focke-Wulf 190D and Messerschmitt Me 262 promised revolutionary capabilities, yet even their limited successes were overshadowed by logistical chaos. Jet fighters required fuel types that Germany could scarcely refine, spare parts that never arrived, and runways constantly cratered by Allied bombers. Pilots often flew once and never again, not because they were shot down, but because their aircraft lacked replacement engines. The Thunderbolt, meanwhile, symbolized a terrifying continuity. Machines replaced faster than they were destroyed. Inside briefing rooms at Karen Hall, high-ranking officers examined reports detailing the Allied industrial machine. Tens of thousands of trained laborers, thousands of subcontractors, and automated assembly lines spanning entire states. For the first time, Luftwaffe analysts quantified defeat, not by tactical losses, but by tonnage of aluminum and gallons of aviation fuel. Statistical warfare replaced romantic notions of valor. General Adolf Galland, once confident in Germany's aerial ingenuity, grew openly disillusioned. He later wrote that the Luftwaffe's downfall stemmed not from lack of courage, but from an industrial mathematics the Reich refused to understand. The Thunderbolt was no longer seen as a weapon. It had become a statement of civilization's evolution, a harbinger of wars defined by logistics rather than legends. By autumn, the Luftwaffe's strategic briefings grew shorter, more perfunctory, their tones subdued beneath the roar of Allied bombers overhead. In those dim command rooms, the realization settled like dust over maps of shrinking territory. Germany's technological brilliance had reached its zenith, but the future belonged to those who could build endlessly, not merely invent beautifully. As 1945 dawned, the ruins of Germany bore silent testimony to the failure of intellect without infrastructure. The Rechlin engineers who had once crowded around the Thunderbolt's gleaming turbosupercharger now worked under candlelight amid shattered laboratories. Allied bombing had erased not only machinery but morale, and every surviving document, sketch, and testing log from the P-47 analysis became evidence of a civilization overwhelmed by its own limitations. Those who had spent careers mastering metallurgy, aerodynamics, and mechanical artistry now understood that knowledge alone could not win wars against factories that never slept. Engineer Otto Behrens, once proud of Germany's precision heritage, reportedly wept as he reviewed production statistics captured by Allied intelligence, numbers proving that while the Reich had manufactured fewer than 40,000 aircraft in 1944, the United States had produced more than 96,000. The scale defied imagination. America's war machine was not merely functional, it was self-replicating, an ecosystem of industry that turned iron ore into engines faster than any human calculation could predict. To the engineers who had once dismissed American methods as crude, this realization was annihilating. In the final weeks before Germany's surrender, remnants of Rechlin's technical teams were ordered to destroy sensitive data before advancing forces arrived. Yet some refused, preserving the Thunderbolt reports as historical warnings. Hans-Werner Lerche, interrogated by Allied intelligence after the war, described his evaluation flights not as triumphs of aviation science, but as glimpses into a future Germany could never reach. He admitted that while the Reich had pursued elegance, the Americans had pursued efficiency, and efficiency, multiplied across continents, had become invincibility. When the Allies occupied Rechlin in May 1945, they found fragments of blueprints and battered instrumentation still bearing traces of oil from the captured Thunderbolt. Among them lay a handwritten note by an unknown technician. "Power without limit is the true weapon." It was not boastful, it was resigned. The men who had dissected the Thunderbolt came to represent Germany's intellectual reckoning. They had uncovered a truth that transcended aviation or engineering, that wars in the modern age were no longer won by genius alone, but by the collective force of nations that could build, replenish, and endure beyond exhaustion. When peace finally returned to Europe, the story of the captured Thunderbolt faded into archives, yet its meaning continued to echo through the corridors of every post-war research institute. The engineers who had studied it understood that they had witnessed more than a technological marvel. They had confronted the industrial destiny of warfare itself. The P-47, with its massive frame and unyielding power, symbolized the transformation of conflict from human craft to mechanized creation, a revelation that would shape every doctrine of the Cold War and beyond. In the ruins of Germany, surviving engineers found employment in Allied laboratories, where they contributed their skills to new programs under entirely different flags. Their reports on the Thunderbolt's turbosupercharger and material composition were quietly absorbed into Western aviation science, influencing early jet development and transatlantic design philosophies. The lessons learned at Rechlin became unspoken foundations for a new generation of aircraft that prioritized durability, modularity, and mass production compatibility. In America, these principles evolved seamlessly into the jet-powered century, proving that the P-47 had not merely won battles, it had rewritten the industrial language of air power. Yet behind every innovation lay the memory of that moment in 1943, when German engineers realized that they were fighting against a machine built not just by engineers, but by an entire nation united in purpose. The Thunderbolt embodied the convergence of democracy, engineering, and economics, a weapon that drew its strength from freedom's ability to organize itself efficiently. Its roar in the skies above Europe was more than sound. It was the voice of an industrial civilization, announcing that modern war would forever belong to those who mastered production, not perfection. By the time the world entered the nuclear and jet age, the lesson of the Thunderbolt had already taken root in every strategic command room. No future war planner would underestimate the invisible power of manufacturing. The P-47 became a timeless reminder that technology divorced from production was powerless, and that courage, though eternal, could never outfly a factory's rhythm. As history closed the chapter on World War II, the legacy of the Thunderbolt endured, not merely as a machine of war, but as a monument to human ingenuity's ultimate paradox, that true strength arises not from the few who design, but from the millions who build.